Hi, welcome back to College Algebra, Math 111 from Mountain Community College. We're going to go ahead and keep working our way through Chapter 1. Specifically today, we're going to talk about function arithmetic. Now, we've already in previous sections defined functions and looked at the domain and the range of functions, and we looked at how to evaluate functions. And now we're going to talk about kind of how we can combine functions together. So let's just suppose that f and g are two functions, any functions. It doesn't matter what they are. And we're going to take some number x that is in the domain of both f and g. And I'm actually going to go to Desmos here real quick. All right, maybe it'll be real quick. And I'm going to open up a Desmos chart. It'll kind of help us understand what we're doing here. So let me go to Desmos. Remember that Desmos is one of my favorite graphing utilities. It might even be my favorite graphing utility. And you can find the link to Desmos under the Online Tools and Calculators module in the Canvas website. I'll go ahead and sign in here for a minute. And now let me find my graphs. Sorry, I really didn't plan this out very well. There we go, open graph. Oh. And this one, whoops, not that one, this one. Okay, let's see what I've got here. Why do I have a blank graph? Oh, because I need to click there. Okay. I'm going to, so we're going to say that we've got one function f. Okay? And I'm going to use a different g because this one's kind of convoluted. So let's use a function that is 3 minus 4x. Let's see what that looks like. Okay, that'll work. And let me just zoom in here a little bit so we can kind of see what's going on. Actually, I'm going to make this a little bit wider. Oops. There. Okay. I like that. All right, so now these are two functions. One is a straight line. The other is a parabola. They both have got a pretty simple domain. The domain for both f and g is all real numbers, yes? So that means I can pick any number I want to. So for example, what I want to do is I want to talk about what we're doing when I say function arithmetic. So this slide with all of these words on it, where it says the sum of f and g denoted by f plus g of x. So what does this mean? What does f plus g of x actually mean? What it means is I'm taking the output from f and I'm adding it to the output from g. So let's, for example, look at x equals 1. So, all right, let's look at x equals -1. That'll be better. Okay, so I just turned on 2 points. This red one is the point -1 comma f of -1. In other words, if I plug -1 into my function f, I will get out a y of 3. Okay? If I plug -1 into my function g, 3 times -4 times, or 3 minus 4 times -1. Well, 4 times -1 would be -4. So 3 minus -4 is the same thing as 3 plus 4, which is 7. So this should be a 0.17. Yes. Now, what I said was that I can write the sum of these two functions. So f plus g of x is the same thing as taking f of x plus g of x. Okay. So f of x, f of -1 is 3. F of 7 is, or g of -1, sorry, is 7. So if I add those two together, I'll have 10. And that's what this point gives. Whoops, wrong one. Sorry. That's what this one gives me. It will in a second. Right? Now, if I do that exact same thing for every x in both of these functions, I will get this curve, the purple one, that represents f plus g of x. In other words, this purple curve is what happens if I take every single x and for every single one of these x's, add to it the output from g and from f. Let's make this a little bit more drastic. Let's change my function g. Okay, let's make that a square. All right, so you see what's happening? Probably not yet. What we're doing is we are taking f of x and adding to it g of x. So this f plus g of x is just a fancy way of saying f of x plus g of x. I can do the same thing with addition, subtraction, multiplication, and division. And we're going to do some examples here in a minute. At this point, what I want you to be able to understand is that when I write f minus g of x, what I really mean is f of x minus g of x. And if I write fg of x, I want you to think f of x times g of x. Okay. And if I write f over g of x, I want you to think f of x divided by g of x. Now there's one caveat on this last one. We can never divide by 0, so that means we have to limit the domain so that we exclude any value that would make g of x be 0. All right, let's work some examples. Let's say that f of x equals 6x squared minus 2x, and g of x equals 3 minus 1 over x. Okay? Let's start by finding f plus g of x. So I told you a minute ago that f plus g of x is a shorthanded way of writing f of x plus g of x. All right, now f of x is 6x squared minus 2x, because that's what my definition tells me, plus g of x, which is 3 minus 1 over x. And this just says simplify. Well, okay. The simplified form of this is just exactly what's there. 6x squared minus 2x plus 3 minus 1 over x. That's it. That is the simplified form of that sum. Let's go back out to Desmos here. And let's see, my function is f is 6x squared over 2x. My g of x is Cool. What was that? All right. This. Okay, let me turn off the noisy stuff. So I've got two curves on here. This is, the red one is f of x, 6x squared minus 2x. The blue one is g of x, which is 3 minus 1 over x. I said in my work a minute ago that the curve f plus g of x would be given by y equals 6x squared minus 2x plus 3 minus 1 over x, which looks like that funky thing that's going on right there, yeah? Notice that 0 is not included in the domain of g. Why not? Yeah, because we can't divide by 0, yes? So that means that Desmos doesn't do a good job with this. Wait, maybe it does. Let's see what happens if I turn off f. 0 should also not be included in the domain of f plus g. So we're going to ignore that, but really remember that x equals 0 is not in the domain of this function. Later in the class, we're going to talk about some things called asymptotes, and we'll talk more about that when this happens. But so this is what I think the answer is. Let's see what Desmos says the answer is. All right, so sure enough, if I turn on my Desmos version of f plus g of x, that is exactly what I said it was. Okay, so all we did was we took the definition of f and added to it algebraically the definition of g. And that gave us the result of 6x squared minus 2x plus 3 minus 1 over x. So I'm going to actually put that in my presentation here. Okay, so we've got that one saved. Oh, look at there, even showed up over here. Okay. Let me erase my chicken scratch. Hopefully that made sense. Let's try the next one. Let's try subtraction. So to do subtraction, we do pretty much the same thing. We just have to be careful with our subtraction sign. So f minus g of x. Whoops, not highlighter. Ink pen. F minus g of x. That's f of x minus g of x, which is just 6x squared minus 2x minus the entire function, the entire definition of g, which means what we really have is 6x squared minus 2x minus 3 plus 1 over x. Let's use Desmos to check that while we're at it, since we've got everything in already. So all I need to do is change this to a minus, and this to a minus, and that to a plus. And sure enough, so Desmos tells me that this graph on the screen right now represents f of x minus g of x. And if I check my algebra by turning on what I think is the right answer, sure enough, it lines all up. I'm going to play with this just a second. Maybe I am, maybe I'm not. Yeah. I'm going to make this be black dotted so that I can see my other graph behind it. There we go. So now I can see whether or not they lay on top of one another. So the solid purple one is what Desmos thinks would be the correct answer. And this one is what I think is the correct answer, and they line up. So my algebra works. What I hope you're understanding is that this algebra is the same thing, or this curve is the same thing that we would get if we did that manual subtraction for every single point on this curve, because that's really what we're doing. Okay, so if I took this function f, and for every x, subtracted from the y that goes with the f, subtracted from that the g, the y that comes from the g, I would get that curve there. It's easier to do it with algebra than it is to do it on the graph. Okay, so, okay with addition and subtraction? Let's try multiplication. Okay, let me put in my answer here. All right, let's erase my chicken scratch. And talk about multiplication. Multiplication is really the same thing, it's just we're multiplying. So f times g of x. That's the same thing as f of x multiplied by g of x. So that would be 6x squared minus 2x multiplied by 3 minus 1 over x. Okay, now things get a little interesting because we have a binomial multiplied by a binomial. So remember, we have to FOIL. And FOIL stands for first term times first term. So that's 6x squared times 3. That's going to be 18x squared. Outer times outer, and the minus sign is stuck to the term that it follows. So that's 6x squared times negative 1 over x squared. So that's going to be minus 6 over x. Nope, sorry, that's not right. Minus 6x is what that should be. I stands for inner term times inner term. So that's 2x times 3 is another minus 6x. And then the L is last times last. So I've got negative 2x times negative x, or negative 1 over x is going to be plus 2. Make sure you know how to do this part. Okay? And what we end up with is 18x squared minus 12x plus 2. All right, let's go check my work. I hope you're kind of seeing how I'm using Desmos here to check myself. It's not going to give me the answer, but it's going to help me check my work. So f of x times g of x. Well, it's a parabola. That's a good sign. Let's see if I've got the right parabola. What did I say it was? 18x squared minus 12x plus 2. All right, moment of truth. I'm going to turn it on. Hey, look at there. It works. All right, so what I did was I took every y from this parabola, multiplied it by every y on this function. When you do that, you get a different parabola. And that's because of the algebra. When I multiply 6x squared minus 2x by 3 minus 1 over x, I get 18x squared minus 12x plus 2. And that is the function that defines this product. Or rather, that is the function that is defined by the product of these two functions. Oops. There we go. Okay. Questions? Let me know if you have any. Email me. We'll talk about this in class too. All right, let me put my answer in on my slides. So this equals, I'm going to insert an equation. 18x squared minus 12x plus 2. Okay. Let's erase my chicken scratch and we'll do the last one, which is division. So what I hope you're noticing is we're using the skills that we developed in earlier math classes, but we're using them to support our understanding of algebra at a deeper level. So in this class, we aren't going to worry, we're not going to focus so much on skills. I'm going to kind of assume that you have the skills, but if you don't, you're going to have to work on that. But I will answer your questions. So please don't think that just because I'm kind of flying through this, I'm not willing to answer questions, because I am. But I want you to understand what's going on as much as how to get these answers. So let's worry now about division. So what I've got, and this is going to get a little trickier because we're going to actually have to use our algebra skills a little bit more here. So f over g of x, that is the function f of x divided by the function g of x, which is 6x squared minus 2x all over 3 minus 1 over x. Now remember, there's two ways to handle this. Probably the simplest thing to do is take this denominator and find its denominator. We only have one fraction here. The denominator is x. So what I'm going to do is I'm going to multiply this whole thing by 1. But 1's going to look funky, because 1 is going to look like this denominator, x over x. So any number divided by itself is 1. So what I've really done is utilized what my math teacher used to call dirty trick number 990, which is multiplication by 1. Doesn't change any values, and I don't have to do anything to the other side, which is good because I don't really have an other side. But I can always multiply by 1. So that's what I did. I multiplied by 1. It just looks weird because it looks like x over x, but it's still 1, right? So long as what? So long as x does not equal 0. But that's okay because we already know that we have to exclude x equals 0 from our domain. Yes? Okay, so now I'm going to distribute. And I'm going to get 6x squared times x is 6x to the third. 2x times x is 2x squared. Divide this by 3x minus 1. Oh, that looks better. I at least don't have a fraction over a fraction. Now, though, I still need to simplify. And here's how I'm going to simplify. I could use long division, but I don't need to here. Look at this top expression. It's got a common factor of 2x squared. Let's factor that out. And I'm going to end up with 3x minus 1. And I still have 3x minus 1 on the bottom. Oh, looky. Those cancel. And my division simplifies to 2x squared. So f over g of x equals 2x squared, so long as x does not equal 0. And what else? There's two things. X cannot be 0. What else can x not be? Let's figure it out. The other thing that can't be 0 is g. So 3 minus 1 over x cannot be 0. Add 1 over x to both sides, solve this, and we're going to get x cannot equal 1/3. So my domain for this part here would be, ready for this? Negative infinity to 0, union 0 to 1/3, union 1/3 to infinity. Okay? Let's put my answer on here. Actually, let's use Desmos first to check me. So we'll put a divide by in here. Well, it's a parabola. That's a good sign. Let's see if it's the same parabola I think it is. I think it's 2x squared. Got all this other stuff. And hey, looky, there it is. Okay. So let's go ahead and put that on my slide. And let me put in a domain for that one too. And I'm just going to write x. Oh, here's my not equal to. There it is. So that's one way of writing this. Sorry, I need to take this. Hold on, I'll be right back. Hello? All right, I'm back. Okay. I hope that this made sense to you. If it didn't, please put something on the forum so that I know what to answer. The thing you need to remember is these translations. Oops. So let me erase my chicken scratch so that this is not quite so crowded. We're getting there. Okay. So you need to know how to do this stuff that I did here. And in order to know how to do that, you need to know these translations. Okay? So that's the basic algebra or arithmetic of functions. We'll talk about another thing we do with functions in another presentation. But right now, I need to talk to you about something called the difference quotient. And the difference quotient is something we determine for a given function. So I'm going to put an example up, and then we're going to do the arithmetic here. But this is f of x plus h. So this is the functional value at some spot, some x, that we're just calling x plus h. Then we subtract from that the functional value at x, whatever x might be, and divide that by h. So let me go back out here to Desmos and kind of explain what's going on here. And let me just do this. There's probably an example out here, but this is going to be quicker. Maybe. Okay. Let's pick a function. Let's say f of x equals 3x squared minus 2x plus 4. Minus 4. Okay, that'll work. Let me put this in projector mode so it's easier to see. Okay, now what I'm going to do is I'm going to just pick an x. It doesn't really matter what x I pick. So I'm going to pick, and actually I'm going to make this thing a little broader. I don't like it being missed. There, I like that better. Okay, and now I'm going to pick, say, x equals 1. So I'm going to put in the function, or put on the point 1, f of 1. This is my x value, okay? And actually, I'm going to make that an a. And I'm going to be able to move my a around. Okay, now, I'm going to put another value on here. And that value is going to be the point a plus h, comma, f of a plus h. And I'm going to be able to move my h around. So we'll make h be 2. Okay. Now, what I want you to understand is what this difference quotient is. So I'm just going to put it in. Can I do that? Give me a second. What happens is when I do this difference quotient, I'm actually finding the slope of the line that would go between those 2 points. So give me a sec to come up with that equation, because I didn't think this all the way through. And that pen is dead. Okay. All right, so let me see if I can do this. I'm going to put in a line that I hope goes between those 2 points. So that difference quotient is f of a plus h minus f of a, and that should look a little familiar to you because those are the y-coordinates of my 2 points, divided by, now I said that, so let's just put in the difference in the x's. So that would be a plus h minus a. Now you should be thinking, hey, wait a minute, that simplifies to h, and you're right, it does. I'm going to multiply that by x minus a, and then I have to add to that f of a. All right, this is just the equation of the line that goes between those 2 points. Now, to make my life a little simpler, I'm going to limit its domain to a is less than x is less than a plus h. There we go. So notice what I did right here. This thing that I have in here for the slope of my line, that is the difference quotient. And if I change my h, that difference quotient is going to change because the slope of that line is going to change. But this difference quotient is the slope of the line that goes between these 2 points, this one and this one. Right? And what happens if I move my reference points? Let's say I pick a different x. Well, my slope changes, yeah? What happens if I move my h closer and closer? Yeah, I can do that. But my slope is still going to change, right? Notice that my curve it changes as I move along my curve relative to the shape of the curve. And guess what? This works for any curve. So let's make this a cubic. Okay? So if I move my points along, see what's happening here? So this difference quotient gives me the relative rate of change between any 2 points on a curve. Gives me the slope of a line drawn between those 2 points. That is what the difference quotient is. Now, this is a lead up to something you'll do in algebra, and we're going to do these a lot through this term, so you really want to work hard to make this make sense to yourself. Understanding what's going on physically on the graph is one way of helping it make sense. The other way of helping it make sense is understanding the algebra. So let's take a look at the algebra. So we're going to do 2 examples of this. We're going to first work with the function x squared minus x minus 2. Okay, I thought I had a blank slide in here, but well, maybe I can put one in. Let's see if I can do this. Oh, that's pretty slick. Okay, my function, f of x equals x squared minus x minus 2. I want my pen. Okay. So f of x equals x squared minus x minus 2. And what I want to find is f of x plus h minus f of x all over h. So the first thing I need to do is find f of x plus h. So that means take x plus h and put that in everywhere we see x's. So that's going to be x plus h squared minus x plus h minus 2. What I just wrote down is f of x plus h. So that's one quantity. From that, we're going to subtract f of x, which is x squared minus x minus 2. This is f of x. And we're going to divide all of that by h. Okay. We have some algebra to do. First thing we need to do is work in here and FOIL this x plus h squared. Remember how to square a binomial. This is absolutely critical. If you don't remember how to do this, go brush up on it a little bit. But this is going to give us x squared plus 2x plus h squared. Now distribute that negative sign. So get minus x minus h minus 2. All of this comes out of this first set of brackets. Now, let's take this negative sign and distribute it through this way. So we get minus x squared plus x plus 2. We're going to divide all of that by h. With me so far? And remember what we're doing. We're finding this difference quotient. So this is equal to this whole thing. Okay? All right, deep breath. Now, let's cross out things that will cancel and simplify where we can. We've got an x squared minus an x squared. We've got a negative 2 plus a 2. Oh, hey, this isn't looking so bad. And I've got a negative x plus an x. Oops, I missed one. This is 2xh. There we go. Okay, so now what do I have? I have my difference quotient. Is equal to 2xh plus h squared minus h all over h. We can factor an h out of this numerator and then cancel out the common factors, and what we end up with is h plus 2x minus 1. And this is the difference quotient. Okay, if I were to go back out to Desmos and reset my function so that it is what I'm working with, which is x squared minus x plus 2. Yes, minus 2. Okay. And because Desmos is Desmos, I had to use an a instead of an x. But let's go look at what I got. I got h plus 2x minus 1. So in Desmos, I'm going to just check that by putting in the line y equals h plus a minus 1. No, h plus 2a minus 1. Oh, I know why. 2x. No, this isn't going to work. Sorry. No can check on Desmos this way. Desmos is only good for helping you understand what's going on. Okay. All right. So for this function, f of x plus h minus f of x, oops, divided by h, we said was equal to 2x minus 1 plus h. 2x minus 1 plus h. Okay? All right. Let's try it for different functions. So let's go back out here. And you know what? Let's just make another blank slide. I really like being able to do that. Look at there. And let's try the same thing with g of x equals 3 over 2x plus 1. So I've got g of x equals 3 over 2x plus 1. And what I want to find is g of x plus h minus g of x all over h. That's going to equal 3 over 2 times x plus h plus 1 minus 3 over 2x plus 1. Well, this is going to be ugly. All over h. This is kind of obnoxious. But what we have to do is find our least common denominator, right? We're going to pull the h out for a minute. I'm going to write that as 1 over h times this thing that we're going to be working on here. So my common denominator is going to be the product of these two denominators. So I'm going to end up with 3 times 2x plus 1 minus 3 times, I'm going to just leave that as 2 times x plus h plus 1 all over 2 times x plus h plus 1 multiplied by 2x plus 1. Okay, we're going to leave it just like that for a minute. We have no reason to multiply that denominator out. We're just going to leave it alone and see what happens. Let's work on the numerator. You guys with me so far? Make sure you understand how I got to where I'm at. And ask questions on the forum or in an email if you don't understand this. Okay, so we're just going to leave the 1 over h times. I'm going to distribute in the numerator 6x plus 3 minus, I'm going to distribute the negative 3 through, and that's going to give me 6 times x plus h minus 3 all over 2 times x plus h plus 1 times 2x plus 1. Ugly. Let's distribute that negative 6 through. Something might be happening that's going to make life a little simpler. So we've got 1 over h times 6x plus 3 minus 6x minus 6. Ooh, I'm liking this. H minus 3 all over 2 times x plus h plus 1 times 2x minus 1. And look at what's going to happen. This isn't so bad. 6x minus 6x, oops, that's an h, plus 3 minus 3. And I am just left with, red, 1 over h times negative 6h over 2 times x plus h plus 1 times 2x minus 1. Okay, and look at what's going to happen. My h's are going to cancel, and my end result is going to be negative 6 over 2 times x plus h plus 1 times 2x minus 1, and just leave it like that. No need to do that multiplication in the denominator. So let's put that in my presentation for completeness. I know that that's a lot to absorb, but once you do a few, it won't be so bad. So what we found was g of x plus h minus g of x over h was equal to negative 6 over 2 times x plus h plus 1 times 2x minus 1. Okay. That's it for this lecture. What I want you to understand is the basic algebra, or arithmetic, rather basic arithmetic of functions, and how to find the difference quotients. This was section 1.5. This is section 1.5. I know the presentation said 1.6 at the beginning. It's actually 1.5. My slides are a little off from the book. This is section 1.5. So work on the section 1.5 homework. Bring any questions you have to class, and I will see you all soon. Have a good night, have a good day. Do a little math. Bye.